Welcome back to our channel Physics Tutorial. This is part 12 video of electric charges and fields. If you have not watched till part 11, please watch it before going ahead with part 12. Today we are going to discuss one of the application of Gauss's law. In the last video also we have discussed another application, that is field due to an infinitely long straight conductor. Today we are going to find the field due to a uniformly charged infinite plane sheet. Okay, so we can go to the diagram. Here we can see an infinite plane sheet and which has a charge density of sigma, that is it has surface charge density, so we can represent it as sigma. Okay, and here we can consider a point P that is very close to this infinite plane sheet, and we have to calculate the electric field at P. So how we can find the electric field at P? So we can use this Gauss's law. Okay, so for that what we have to do, we can consider a Gaussian surface. So here also we are taking a Gaussian surface in the form of a cylinder. Okay, and which has an area of cross section ds. Here we can apply Gauss's law, that is according to Gauss's law we have integral E dot ds is equal to 1 by epsilon 0 q. So that total flux we have to find. Right, so that will be E into integral ds, that will be equal to q is sigma ds, that is sigma ds divided by epsilon 0. Now we have to find the flux. So here we can see that there is no lateral flux. So the flux will be only through the end surfaces. So here we have ds as the cross section and E is the electric field. Okay, so what will be the total flux through the two surfaces? So that means that two end surfaces we will get E into 2 ds, that will be equal to sigma ds by epsilon 0. So from that we can rearrange this to get E. So E is sigma ds by 2 ds epsilon 0. Here ds and ds will get cancelled. Now then we can get E is equal to sigma by 2 epsilon 0. Okay, so that is the equation for electric field we are considering uniformly charged at a small distance from the plane sheet, and we can assume a Gaussian surface in the form of a cylinder. Okay, then we are applying Gauss's law. So what is Gauss's law? Integral E dot ds is equal to 1 by epsilon 0 q. Here we have to get the value of q, right? So here we have a surface, so we will be having surface charge density sigma. So how we can find q? Q will be equal to sigma ds. So that we are applying here. So that is E into integral ds is equal to sigma ds by epsilon 0. Now we have to integrate. Here we have the electric field only through the end surfaces because we have two end surfaces. So the integral ds will be 2 ds and there is no lateral flux. So we have to integrate here. Okay, so what we will get? E into 2 ds, that will be equal to sigma ds by epsilon 0. Now we can rearrange to get E, that will be equal to n ds by 2 ds epsilon 0. Then ds will get cancelled, then E equal to sigma by 2 epsilon 0. Hope it is clear to you. If you have any doubts or suggestions, please comment. Now we can wind up the video. If you like the video, please like, share and subscribe. Thanks for watching.